Hi, this is Riyaz. Now I'm going to explain the problem missing a point, which was given in July long challenge in Codechef. This problem is quite interesting because it seems a little hard, but it can be solved easily. Okay, let's get started with understanding the problem statement. This was the problem statement given. Chef has an axis parallel rectangles in a 2D Cartesian coordinate system. This point actually means that all sides of all the rectangles are parallel to any one of the axes in the coordinate system. Let's see it diagrammatically. Assume this one has x-axis and this one has y-axis. According to that point, a rectangle, a test case with this type of rectangle can exist, and a test case with this type of rectangle can also exist because two sides of this rectangle are parallel to x-axis and the other 2 points are parallel to y-axis. These rectangle sides are also parallel to any one of the axes given. That point also means that a rectangle with these vertices cannot exist. Such rectangle cannot exist because the sides of these rectangle are not parallel to any one of the axes. These rectangles may intersect, but it is guaranteed that all their foreign vertices are pairwise distinct. According to this point, a test case with this type of rectangles can exist. Here we can see that these two rectangles intersect, but none of their vertices coincide at a point. But a test case with this type of rectangles cannot exist because one vertex of this rectangle and the other vertex of this rectangle coincide at a point. Unfortunately, Chef lost one vertex and until now none of his fixes have worked. Therefore, he gave you the task of finding it. You are given the remaining 4 and minus 1 points and you should find the missing one. Assume you have n rectangles, then you will be given 4 and minus 1 points and you have to find the missing one. For example, consider we have 3 rectangles, n equal to 3, then 4 into 3 minus 1, 11 points will be given to you and you have to find the 12th point, which is considered to be missing. Let's see the input. The first line of input contains a single integer t denoting the number of test cases. The description of t test cases follows. The first line of each test case contains a single integer n. Let's see the sample input given. Here one is the test case which is t, and in the next line we have 2 which is equal to n, that is number of rectangles, and from here you will be given 4 and minus 1 lines. You have to print the missing point. These are the constraints given for this problem. Subtask, and these are the subtasks. Subtask 1 contains 20 points, subtask 2 30 points, subtask 3 50 points. That was all about the problem. In addition to this, you are given explanation about the test case. Let's analyze this one. These are the 2 rectangles given in the problem. In 4 vertices of this rectangle, you can see that these two x coordinates will be equal and these two x coordinates will be equal. Similarly, the y coordinates of these 2 vertices will be equal and the y coordinates of these 2 vertices will be equal. I'm saying that they will be equal because they lie on the same line, and I have listed those 4 vertices here. You can observe that here each of the x coordinate occur twice and each of the y coordinate occur twice. 3 occur twice in y coordinates, 3 occur twice and 6 occur twice. In x coordinates, 4 occur twice and 9 occur twice. Let's take 9, 3 is not given. You are given only these 3 coordinates. Then how to find the 4th one? Assume you are given only these 3 vertices and 9, 3 is the missing one. You have to find this. Then how can you find this one? Means in these 3 x coordinates you have 4 occurred twice and 9 occurred only once. So this 9 will be equal to the x coordinate in the missing point. And in y coordinate 6 occurred twice and 3 occurred only once. These 3 will be equal to the y coordinate in the missing point. In such a way, we can find the missing point for each rectangle. It doesn't matter how many rectangles given because you will be asked to find only one missing point. Up to now, you are clear about finding the point. To implement this, we have 3 approaches: Navy approach, hash map approach, and XOR approach. In Navy approach, we will store the coordinates in 2 different arrays and sort them, and then we will visit through each of the element in array and check whether the right neighbor is equal or not. In this approach, what we actually do is in problem we will be given x coordinates and y coordinates. We will store all the x coordinates in one array and we will store all the y coordinates in the other array. After storing these coordinates, we will sort both the arrays, and then we visit through each of the element in each of the array and check whether the right neighbor is equal or not. And after comparison, we will increase the counter by 2. I will explain this with an example. It will be more clear for you. Assume you are given two rectangles in the sense we will be given 4 and minus 1. That means 4 into 2 minus 1, 7 points will be given. That means you have 7 x coordinates and 7 y coordinates. Let's take x coordinates as 1, 7 values. These are the x coordinates for two rectangles. Here we can see that 1 is repeated twice, 7 is repeated twice, and 4 also repeated twice, but 8 occurred once. So this is going to be the x coordinate of the missing point. Let's take another array with y coordinates. These 7 are the y coordinates. These are the y coordinates of two rectangles. In y array you can see that 4 occurred twice, 2 occurred twice, and 6 occurred twice. 9 occurred only once. So this is going to be the y coordinate of the missing point. In first step, what we do, we store these x coordinate and y coordinate separately, and the next step we do is we sort them. This array will be, after sorting, this array will become 1, and next element is 4, then 7 and 7, and last one is 8. So after sorting this array, we will get this 1, 1, 4, 4, 7, 7 and 8. And after sorting the array which consists of 5 coordinates, we will get 2 and 2, 4 and 4, 6 and 6, and last one is 9. So these are two sorted arrays. Then the final step is in the final step what we do is we compare each element with its right neighbor. If it is equal to the right neighbor, then we increase the counter by 2. If it's not equal, then we return that value, and that returned value will be equal to the answer. For in this array, 8 will be written. 8 is going to our x coordinate, and in this array 9 will be written, because while comparing 6 and 9 our comparison will fail and 9 will be written. 9 will be written and 9 is going to be the y coordinate that we need. So this is linear approach. One approach is a hash map approach. In this approach, what we actually do is we'll take two hash maps, one hash map for x coordinates and one hash map for y coordinates. First hash map will return as the x coordinate, and second hash map will return as the y coordinate. That's it, so simple. But we will use XOR approach, that is third approach for this problem to solve, because when compared to these 1 and 2 approaches, third approach has efficient space complexity and less time complexity, so we'll use that one. In this approach we will use XOR operator. Means we perform some XOR operations. What actually XOR operation means, in the XOR operation, bits are compared with one another, just like the AND and OR operators whose 2 bits are identical. It means when 2 bits are identical, XOR will return a 0, and when 2 bits are different, XOR will return a 1 as a result. Or simply we can say that XOR operation between two same values will return 0, and XOR operation between two different values will result 1. Let's see these two examples. Here XOR operation between these two binary numbers will return 0, because the leftmost bit is 1 and 1. XOR operation between 1 and 1 will result 0, and in the 3 cases also it will return 0, so the total result will be 0. And in this example 1 XOR 0 will be 1, 1 XOR 0 will also be 1. Similarly it will result all ones, and the result will be 15. For example, if we take 0 1 1 0 and 1 0 0 as other example, then what would be the result? XOR operation between 0 and 1 is 1, so the first bit is going to be 1, and the XOR operation between 1 and 0 is also 1. XOR operation between 1 and 0 is also 1, and XOR operation between 0 and 0 will return you as 0. So this is how XOR operator works. In XOR approach, we perform XOR operation on first element and second element of the array and store its answer in variable result. In next step, we perform XOR operation on third element and with previous results and so on. Or simply we can say that we perform XOR operation between all the x coordinates and we will store it in a result, and this result variable is containing the x coordinate which we require, and we perform XOR operation between all the y coordinates and we'll store it in other result variable, and this result variable will contain the y coordinate that we require. This is how this approach works. Commutative property means x XOR y will be equal to y XOR x. This is the commutative property for XOR operator. And there's another point you should remember that we discussed earlier. It is x XOR x. That means XOR operation between two similar things will result in 0, and XOR operation between 0 and any value will return the same value. 0 XOR x will be x. So let's take an example. Consider this is the array containing all the x coordinates and this is the array containing all the y coordinates. After applying XOR operation between all the elements in this array will result in 1 XOR 4 XOR 9 XOR 9 and 9 XOR 6 and 6 XOR 1 and 1 XOR 4. We can rearrange them using commutative property. We can rearrange them as 1 XOR 1 and XOR 9 XOR 9 XOR 6 XOR 4 and XOR 4. Now it will be clear for you that 1 XOR 1 will be 0 and 9 XOR 9 will be 0, 6 remains same, and 4 XOR 4 will be 0. And we know that XOR operation between a value and 0 will return the same value, so the resultant value is going to be 6. So the x coordinate which is missing is 6, and this is the y coordinate. This is the array containing y coordinates. Similarly, we can rearrange them as 8 XOR 8 XOR 9 and XOR 9 and XOR 7 and XOR 7 and XOR 4. This also will result 8 XOR 8 as 0 and 9 XOR 9 as 0, 7 XOR 7 as 0, and 4 remains at last. As we discussed earlier, this will result 4. So this is the y coordinate that is missing, and 6, 4 is going to be missing point. From the 3 approaches, I have chosen the XOR approach because in XOR approach we need not store the data in any array. We can use the third variable to store the data, and we can update this result variable. and even the time complexity is less when compared to the above two approaches, that is when compared to naive approach and hash map approach. And the space complexity is also going to decrease when compared to naive approach and hash map approach. So let's write our code here. It is given that you will be given a test case t in the first line. Let's declare the t as the test case variable and scan it here, and I will run a loop which runs until the test cases end, and inside this loop I will declare a int n variable which will be scanned in the second line. After scanning n variable, in the problem it was given that you will begin 4 n minus 1 lines, so you are going to declare a loop which runs 4 n minus 1 lines. I am using here for loop. You can use while loop also. Into q equal to 0, from q equal to 0 to q less than 4 into n minus 1 times, and q variable incrementation. In this loop, what I will do is I will read x coordinate and y coordinate, c in x and c in y. For each test case, I will declare two result variables. First one is result underscore 1 equal to 0, and result underscore 2 equal to 0. Don't forget to declare these two variables with 0. What we will do is result underscore 1 equal to result underscore 1 XOR x. This result 1 variable will result as the x coordinate of the missing point, and result underscore 2 will result as the y coordinate that is missing. Result underscore 2 XOR y. Outside the loop we will bring these two values. See out result underscore 1 and result underscore 2, and new line for every test case, and a space between x coordinate and y coordinate. That's it. But first let's run this one with custom input. Output is 2, 2, which is expected, and that was the answer for the sample test case given in the problem. Let's submit this code. Then you can see all the test cases are passed, and that was the answer, which is simple. Thank you.